Okay, people, solids in contact, sheet 3. Now, this is basic stuff, but it's important to understand the basics of it. So, we want to put a sphere. So you've got the elevation and plan of a cylinder, and you've got a point, and it says to complete the projections of a sphere that's sitting on the ground, horizontal plane, and touching the cylinder at that point. Okay, so here is the point of contact, and there's the point of contact. So just over here in the little pictorial there, what you need to do is move the point of contact out to the outside of the cone, and then you can draw the sphere that sits on the ground, touches it at that height, and then you got to roll that sphere around to the correct position then. So I'm going to bring out the point of contact to the outside, and I'm going to bisect that angle with my 45-degree set square because it's a 90-degree angle. Just heavy that in a bit, and we know if the point of contact is here, the center has to be here also. So there is the center and the point of contact when it's beside it. Now I don't need to draw this here, but I just will because it might help people understand it. So there is the correct size sphere sitting on the ground, touching beside. So I'm going to bring that center down. That is the center when it's beside it. And then I want to roll it around. Now, when it's in its final position, the point of contact is always on the line joining the centers. So the point of contact, the center must be on the line out here. I extend it out through the point of contact, and I am now going to rotate that center. So that's that sphere rolling around the cylinder. So this is my final center. So I'll just set my radius here of this, or I could have set it off here. So here is my so that is the correct position now. So I projected a line out through the point of contact, and here is my final position now. So I need now to project that back up to the elevation, and this here now is the proper position for that sphere. So there's our elevation, point of contact, plan, point of contact. Now question 2. Now these are questions that you can quite easily practice at home because you can just draw a cone and plan, cone elevation, and pick a point. Now we want to find, that's the point of contact. So draw the projections of a sphere which touches the cone at the point and rests on the horizontal plane. So again, it's the same idea. Here's your cone, here is our point point of contact, and we want to draw a sphere that touches the cone at that point. So the first thing I'm going to do is I'm going to put a string from the top of the cone to the bottom of the cone, going through P, and I'm going to bring up, here's where it touches the base, and we know it goes to the top of the cone, and so there's my string on the front view, and P is on that. So this here is the point of contact. So that's step one, to find the point of contact on the front view. Now my next move, now I'm going to take the height of that point of contact out to the side of the cone there. Now the next thing, now I want to bisect this angle here. I'm going to extend this over a bit to do it big. So use big distances for bisecting. So here is our bisector. Now we want to put a sphere in here, but anywhere the center has to be on the bisector. But like obviously if I drew a sphere in here, that's too small because the point of contact is way down there. So how do I know where the center should be? And what you want to do is come 90 degrees off the side of the cone. So here's the angle of the side of the cone. So I want to come 90 degrees and perpendicular to that. Now another way of doing that is you can just use the 90-degree angle there like this, but it's not as accurate as the way I did it. So come 90 degrees out. That is the center for the correct sphere. Now I don't need to draw it in, but look, I will just put it in light there so you can see there's that sphere touching at the right height and touching the ground. So we now know the radius. That's the radius of the sphere we need. The problem is it's beside it, and we don't want it beside it. We need it out in front. So I'm going to bring it down here now to plane. Rotate around. So I brought it down to plane, rotated it around, and I'm going to extend the line out now, because if the point of contact is here, the center must be straight out from that. So there is our final center, and I'll just reset that now to the radius here. So here is our center point of contact. So if the center is here in top view, it's straight up, and the height of the center must be straight across from here. So that there is the final center. And So final center and point of contact. So again, it's the same thing. Move the height, move the point of contact. You've got to find the size of the sphere, the radius, and at the outside, beside the cone, bring it down, roll it around. And now, and there is another way. There is another way to do that, in that you could, I could have taken, and I'll just show this, I'm not going to do all of it now, but I'll just show one tiny part of it, is you could do an auxiliary. If I took an auxiliary here, so basically if I walked around and looked in perpendicular to that line here going through the point of contact, if I project that up, here's the right hand side, here is the left hand side of my cone, here is the top of the cone. Now the cone height is 50 mil. So this here is an auxiliary elevation, a new view of the cone, but now the point of contact is on the outside generator of the cone. So that there now is the point of contact, and we now have the same situation as taking the height across here. We could just bisect the angle, come out at 90 degrees, and that will give, I suppose for the sake of 30 seconds now, I'll just run through it. So bisect the angle, so there's my bisector. Then I want to come out at 90 degrees. So here's my center, and if I project that back down now at the same angle, so I can project that back down, and that gives me the same center there. So that's, that came out a small bit light there now. So that's another way of doing it. So this is done using an auxiliary, and this is done by moving the height and projecting the height across. Now, question 3 here, you've got the planned elevation of a hemisphere, put in projections of a 50mm high cone that touches the hemisphere at this point and rests on the horizontal plane. Okay, so that's a nice question, yeah? You've got a hemisphere here, and you've got to put in the correct sized cone to touch at this point, and the cone must be 50 high. Okay, so that's a nice question. I like it. So first thing I'm going to do there is just put a like a hoop around the hemisphere at the point of contact. So I have it shown in red over here. That's basically a hoop or a circle going through that. Now in the front view, that circle is going to be an edge view, so it's going to look like a line, and here is my point of contact on it. Okay, so that is the point of contact here. Now the next thing we know then is if that point of contact was out here, that's the height of it. So that is the correct height at the outside, and I'm going to use that now. And the next thing I'm going to do then is I'm going to join that to the center here, and I'm going to go off 90-degree angle, and that would be that is a tangent at that height. So that's what the side of the cone is going to look like, and we know this cone is supposed to be 50 high, so I'll just mark up 50 high here. So that there is the center axis of the cone, and if I don't need to draw any more of the cone here now, but I will just to help people understand it, I think. So just stepped out the same distance to the other side there. So that is the cone that touches the hemisphere at that height, and it's 50 high. So my next problem now is, now that we have the right sized cone, we need to just, that's drawn beside it. So I'm going to bring that cone down to plan. That's the center of the cone in plan, and I'm going to roll it around again while keeping in contact. So I'm going to just draw out through here. So the center of that cone has to be on this line here, because it's on the always on the line joining the centers. So that there is the final center for the cone in plan. So I can now draw the base of that. So I'm just measuring the base of the cone here. Now because that's a cone, the cone goes in underneath the hemisphere. So I'll just mark that in dotted there. And now that I know the final position of the cone, I'm just going to bring up, here's the left hand side of the base. Here is the right hand side of the base. And here is the center axis of the cone. We know the height is 50. So there's the apex of our cone. And I'll just heavy in this cone now. So here's the final position of the cone in elevation, final position of the cone in plan, point of contact, point of contact. So nice question, a little bit in it, but again there the key I suppose one of the key learnings of this is if you have your hemisphere and you know where the point of contact is, well, if I join that to the center and go off at 90 degrees to that, that is the tangent. And the height of the cone is irrelevant then, whether it's, because the height of the cone then just tells you where the axis is. So a small cone would be like this, and a taller cone will be like that. But the height of the cone is really irrelevant. It is knowing to join that point of contact to the center and going off at 90 degrees to get the tangent. Now the final one here then is to put a sphere in here that touches the given point. Complete the plan and elevation of a sphere shown as the plan and elevation of a sphere. The given point is on the surface of the sphere. Complete the projections of a second sphere, radius 10, which touches at the given point. Okay, so this one now is a small bit different. So I'm going to just put a hoop around this. So there's my hoop around that. So I want to bring up the outside of that now. And so this is the elevation there. That line is the front view of that hoop, and we know that the point of contact is on that. So here is my point of contact. Just heavy that in a bit so you can see it. Okay, so we want a sphere of radius 10. Okay, now it didn't say that it had to be sitting on the ground. Okay, so because what I wasn't sure of there, if I was to sketch this over here, is are we putting a small sphere down here, or are we putting it up there, the second sphere? And okay, so I just have a suspicion that this sphere might be going under the ground if we do it on the bottom. So I'll just check it out here now. So if it was at the side of, because all of the work needs to be done on the outside here, so if our radius 10 sphere was at the outside, that would be radius 10. So I'll just draw this in and see. Okay, so just about okay. Now if it was going under the ground, so be it, or else you could move the hoop up to the top half and have it up in the air above it. But either way, the principle doesn't change anyway. So there's the center of our size 10 sphere, radius 10 sphere. So again, the same thing now. We have it the right size sphere, but it's beside it. So I'm going to bring it down beside it in plan, roll it around. Now it has to be on a line projecting out from the center of the big sphere here. So this here is my final center. There's the point of contact, and I can now bring up the center. We know it's at this height, so there's my final center and my final point of contact. So I'll just set this now to 10. Not the easiest now drawing spheres this small. So there it is in elevation, here it is in plane. Now a lot of this now, because a small sphere will go rolling underneath the big one, so I'll just dot that in, and that is that.